Here is an example for multitasking. Multitasking means running more than one task. So user is one. For a single user, more than one task are running simultaneously. So here is my diagram. There's a single user and this is the screen of a user, and this is the main memory, and the CPU. Now here on the screen you can see there are two windows. One is MS Word Windows and Chrome. A user is single and he can run more than one application that we normally do it on our PC. So more than one applications are open at a time. So they are running, but which one is active? The one which is visible on the top is active. So both the programs are running simultaneously. So if you see in the memory, I have shown the programs for MS Word program and Chrome program. Both the programs are there in the memory and CPU is executing them simultaneously. Actually, it is executing alternatively. At a time, CPU cannot execute two programs. It can execute only one program. But at a faster rate, it is doing them alternatively. It seems as if they are running simultaneously. So user is using them. So here is in the example, in MS Word, he is typing something, and at the back in the Chrome, some website is open and there is a video. He is playing the video also. So that Chrome is also working and he is also working on MS Word. So more than one programs running simultaneously for one user, that is multitasking, multiple task. So the operating system that supports this type of environment are Windows operating system. So maybe from your childhood you are using Windows only and you have seen only these systems. So these systems are called as multitasking operating system. So Windows is an example, right? And one more is Mac OS, or it was called as OS X. That is also an example of multitasking. And on Linux also there are many environments available, so you can switch in between the environments. Multitasking environments are available. So running more than one task simultaneously for a single user. Now let us move to multi-threading. So here I have a diagram. There is a single application running on the screen, that is Chrome, and some website is open. And the single application, Chrome is an application, program is Chrome, right? Now in that program, this is video is playing, advertisement is shown here, and the ads are changing time to time, ads are changing. And here the comment box is there, user can type the comment at any time, or he can chat with the person behind, or just a comment. So he can do that also. So three things are happening simultaneously. This one example I have taken. Video is playing, advertisement is running, and the comments he can type. Or if somebody has commented on the same video that is popping up, he can see that comment. So three things working simultaneously in a single application. So when it is inside single application, they are called as threads. Just like here we have multiple applications, but here multiple threads in a single application. So threads are inside application, a part of application. So we say they are light-weighted compared to this heavy-weighted programs or processes. So threads are light-weighted. So here if you see inside the main memory, this is a program, right? This is the main memory. The outer box is a main memory, right? And this is a program and this is a Chrome program. Now Chrome program is having main. So as you know, the program in Java starts from main. Even in C, C++, the main method is the starting point of a program. So that is the main method. And these are the threads. Thread 1 for video, thread 2 for advertisement, and thread 3 for comments. You can imagine them like this. So multiple threads are running simultaneously and all three are responding to the user. So user feels as if all are running simultaneously. But the fact is, as I told you, CPU cannot execute all these threads simultaneously. It will execute them alternatively and user feels that as if they are running simultaneously. So for the user, because of the speed of that processor makes the user feel that they are running simultaneously. So we say they are running simultaneously. Multiple threads are running simultaneously. So this is a explanation of threads and also example where multi-threading is used. So the example is a website having a lot of contents and all are playing simultaneously. Now, I will give you more examples on multi-threading where multi-threading is useful. Here I have more examples for explaining you usage of multi-threading. So examples of multi-threading. First one is an animation here. Animation. There are many animations. So one of the example I have taken here, these are balls and these balls are bouncing. So they are bouncing in different directions, right? So these balls are bouncing. This is moving in this direction, this is moving in this direction, and this is bouncing like this on these walls. Whenever it touches the wall, it changes the direction. So the balls are bouncing. Now three different balls are moving independently. So for each ball you can have a thread. So one thread for one ball. So that thread will be controlling the ball. And all are moving simultaneously. It seems as if they are running together, they are bouncing together, but they are controlled by their own thread. So here multi-threading is useful. Most commonly it is used in animations. Now next, I have an example of a game. Car racing game. Here there are three cars on this track and each car is running independently. It may be a multi-user game also, like the people around at different places are playing it on the server, so everybody can see their cars and others' cars also in the race, and each is controlling his own car. So for each user there must be a thread, and with thread it is possible. So his thread will take care of his car. However he controls the car, thread will run the car like that. So this is an example of a game, right? So in games multi-threading is useful. Now next I have one more example. Here there is an application. Think that it's an application. Okay, it's a program. A program showing a person playing a piano and guitar and drums. So this is for orchestra. Now if it is a single program, just a single program, so it has to play piano, then guitar, then drum, then again piano. So it has to do it one by one. But we want all these three things to be played simultaneously, then it has to be controlled by threads. It will have its own thread controlling this piano person and own thread for guitar person and one thread for drum person and one thread for the application, that is the main thread. So this is also an example of an animation type application. Then I have one more example here. We access websites and we know that one website may be used simultaneously by many users across the world. So a lot of users are interacting with the website, lot of hits it is getting. So on the websites, there will be something called web server or web application. So I am drawing this round bubble is a web server. Then that web server has to respond to so many users simultaneously. How it can do that? So for each user, it will start a thread and it will cater the needs of that user or cater the request of that user. So this web server is having threads. So this bubbles I am showing as a threads. Okay, these are the threads. So usually threads means it is drawn like this, just a thread. We draw it like this. So these are the threads. Okay, so bubbles are there. I'm representing them. Now this user is being serviced by this thread. This user is serviced by this thread. So any user makes a request to the website, the web server will start a new thread and that thread will take care of that request and the response to that user. So it is useful in servers. So we are using a lot of servers like you are watching a tutorial on Udemy. So Udemy server is responding to you, it is showing your account and it is showing your own videos. So it is there in the database, right? It is there in the database. A lot of things are there stored, but this thread is taking your profile and pulling your own contents and showing it to you. So simultaneously your friend is also watching. So this is your friend. So this thread will know his profile and he will pull his contents from here and it will show to him. So this is where another place where threads are useful. So these are the examples of threads. Next, I will show you how a single program can have multiple threads or multiple controls. So for that, first I will explain you what does it mean by flow of control. Then we can see how a program can have multiple controls to control different things simultaneously. So let us learn about control flow. So next we have to see control flow. So we will see that in the next video. That's all in this video. We'll understand about flow of control of a program and how a program can have multiple threads. So watch next video for that topic.